Okay, good afternoon, everybody. A couple more hours of KubeCon Europe. So thanks for sticking till the end. Usually, some of the last talks in the afternoon of a conference are always, less attended. So thanks a lot for staying. I think we have some exciting content. Austin did an amazing job earlier this morning. The demo was really, really cool. So my name is Sebastien Goasguen. I'm the Kubernetes lead at Bitnami. I've been in Kubernetes since 2014-15. I did things like Compose, Cabin, the web app, K-Machine. I work a lot on. I worked with the Linux Foundation on certification course, O'Reilly, and so on. At Bitnami, we work a lot on packaging apps. So you may know us from the marketplace on Azure or AWS, Google. We see you see a lot of applications that are packaged by us. Of course, we generate containers, and when Kubernetes started, we got very involved with the charts. So we also build charts and then participate in the community upstream to build those applications. So we're all about apps for any platform. And of course, when we start thinking serverless, it makes a lot of sense for us to get involved. So today I'm going to talk to you about securing serverless functions. So it's a little bit of an advanced topic, but I didn't want to cover the basics again. So I really wanted to dig a little bit deeper into some of the things that Kubernetes gives us out of the box. And those things help us secure those functions. So I'm going to go through some of those topics. And then joining me will be Johannes Engelke. He's right here. He's waiting for his container to download. So let's cross fingers. Johannes works at SAP Hybris, which is the e-commerce platform for SAP. And he's a contributor to kubeless, the project that I'm going to mention. And this morning, if you followed the demo from Austin, you saw that there was one of the functions was a kubeless function running in the SAP cloud platform, which was calling the SAP machine learning system. Okay, so we work very closely with SAP, and they contribute to kubeless. So I thought it would be nice to have Johannes come here and then explain to us how they actually use Istio. So it's not an Istio talk; it's a talk on security, but happens that they use Istio. Okay. So what type of applications are we talking about here? And yeah, the slides are pretty simple. I didn't concentrate on making very fancy slides. As you can tell, it's marked down. So what type of apps are we thinking about here? So of course microservices, so containers underneath running in Kubernetes. But then we're going to have events, and that's where it resonates with what the working group is working on. It resonates with the cloud event specifications, because I believe that future apps will be made of small glue, the functions that will be triggered by events. And when we mean events, it could be of course events in something like Kafka or NATS or one of the more regular enterprise pub/sub, but also cloud events, so events coming from cloud provider services. So machine learning, storage, streaming services, databases, you name it. So all these cloud services are going to emit events, and when we're going to start writing applications, those applications are going to be a set of functions triggered by those events. Not really new, we've done messaging-based applications for some time, but I think that now we're going to have more and more events, and the ease of deploying functions is going to kind of rejuvenate that type of application paradigm. So the whole idea is to compose many different services and trigger them on events. Could be in the cloud, could be on-prem. And of course, here I'm saying AWS Lambda clone. That's meaning that when we look at some of the solutions that Austin mentioned this morning, they are clones, quote, of Lambda. Okay, so systems that allow you to deploy functions. And this is not a talk about kubeless. I'm a very bad sales guy, but I'm going to use this system to illustrate some of the security features that you get out of the box with Kubernetes to help you secure functions. Okay. So, where I'm going with this is that apps are going to be, made of functions triggered by events. Those functions, they are deployed in your Kubernetes cluster. And of course, underneath, they're managed just like regular services. So The rest, you'll see some specifics about kubeless, but they are really here to illustrate what you need to watch out for. So digging into kubeless now, it's really a Kubernetes extension, and we see more and more of this, at this conference and even in the community. There is more emphasis on using custom resource definitions to extend the Kubernetes system. And the idea is that Kubernetes is really becoming a platform on which to build additional systems. So when we think about, how do you deploy your functions? How are you going to deploy that glue? Well, that glue is going to be deployed on Kubernetes via an extension of the Kubernetes system. So it's all based on CRD, you have a controller, and in the end, you deploy, you have deployments and services and so on. Kubeless also has serverless plugin. That's a shout out to Austin this morning. I think we can do better than his event gateway, but don't tell him, okay? But he has a great system. So to start digging into a security aspect, if we look at the original architecture of kubeless, which was really meant as a POC at the beginning, was quite simple. Let's extend the Kubernetes API with a CRD, and that CRD is going to basically allow us to have a function object, kind function. And then when you create a function, so you have a manifest for a function, you have your kubeless controller, so your controller sees that object and then creates a deployment. That deployment then launches a pod, and in that pod you inject a function, okay? That's actually quite easy. Yeah, I'm going to say easy. That's actually quite easy to do. It's just a single controller, a CRD definition. And if you stay at this in terms of serverless, basically, 2018 CGI, that's a relatively simple system. Now, I really think that the trick comes when you have to trigger those functions when you have events. Okay, so that's going to be really the value add of those systems. So we spent quite a bit of time recently trying to, we achieved it. We solved that problem. We cracked it. We re-architected kubeless. And I'm not going to show it to you like a lot of details, but now we actually have event triggers that are defined as new CRD objects. So if you want to trigger on an event in NATS, we define a NATS trigger. If you want to trigger on an event in Kafka, you have a Kafka trigger. If you want to trigger on a SQS message, you have an SQS trigger object. Okay, you get the idea, you get the drift. So now all your cloud services out there, Kinesis, Google Storage, and so on, you're going to be able to define a mapping between an event and a function using a Kubernetes CRD. So I think this is really, really interesting, and it opens, a ton of doors. So that's the overall architecture. But what about the security features? And we have people, they're saying, hey, we want to use kubeless, but we're on OpenShift. We have big security, requirements and so on. So we need to really think about the security of that system. So I at a high level, I said two types of security: internal security, and then external. So internal, I mean authentication, authorization, who can create functions and manage them, delete them, modify them, and so on. How can you limit what a potentially compromised function can do? And then things like auditing and logging and so on. I'm not going to talk about auditing and logging because you get that out of the box with Kubernetes. It's just a setup. And then external security. So you've deployed your function, you have your authentication, RBAC, and so on. External security, I mean, who can authenticate? Who can talk to that function endpoint? Okay? So how are you going to enable this? Usually it's some type of authentication at the ingress layer. Okay? And then I think the next problem is really what can the function do in terms of talking to a cloud service? And to be able to talk to a cloud service, you need to have an identity. You need to have an authentication profile, a YAM profile, something like this. So when you start thinking about this, now your function needs to leverage POID identity functionalities. Okay? That was lots of bullets. If you prefer a picture, it looks like this. Okay. External security, who can call it? Ingress, and then what's the identity of the function to talk to other services, and namely to be able to consume those events, for example. And then internal, I'm going to really talk about this. Authentication, solved out of the box because your system, if you base it on Kubernetes, a function is now a custom object. So you have authentication out of the box. You use the authentication mechanism of the Kubernetes API server. Okay? So here, you see the example of the function object right now, API version kubeless IO v1 beta 1. The kind is function. And then, of course, you have the metadata. You have everything that comes in Kubernetes. So authentication solved. And I think that's really the way you should design that system. If you have to build your own function API server, I think it's not the right way to do it. So here we leverage the authentication system of Kubernetes. And of course, out of the box, you also get RBAC. Okay, it's just another object. So if you create a Kubernetes cluster with RBAC enabled, and then you see here at the top, I say kubectl get functions in a specific with a specific context, which is just a different user that's not allowed to do anything. You see it says, hey, cannot list functions. So typically that's because the RBAC role, the user making the call doesn't have the RBAC role to be able to do the function. Then you see that I create a role binding, and now I do a get function, same call, and now it says no resources found. So, nothing magic here, but that's out of the box because, kubeless or any other system, actually like Nucleo, or I haven't checked FN or Riff, things like this. By basing their function system on top of Kubernetes, they get all of that out of the box. And then if we start thinking about the isolation of those functions, then it's great because it's a Kubernetes native object, so you have namespace isolation. So get function in the default namespace, get function all namespaces, suddenly you see another function show up, okay? So you get namespace isolation. And suddenly it starts becoming super interesting to have namespace isolation and also to have support for labels, okay? And this is just standard Kubernetes. Yeah, I'm guessing some of you know this, but you see at the top, I'm creating a function. So that's the typical kubeless CLI. So kubeless function deploy. And at the CLI, I can define some labels. So you could write a function as a function manifest, but you can also use the CLI. And then we have this, I call that convenience to be able to define the labels. So now you have a function object that's going to be created, that's going to have labels. We propagate those labels to the pod that's going to serve that function. And what does that mean? It means that suddenly you're going to be able to use network policies to isolate your functions between, each other or other things, okay? So the fact that your Kubernetes native, authentication, RBAC, namespace isolation, label, supports for label, which then opens the door to network policy. Here you see a network policies that says, hey, all the pods that have the tag label foobar, you allow ingress from pods that have access equal true, okay? So you can stop incoming traffic to your function, and then, it's just an example. I'm going to spare you the demo because it just works, okay? So, honestly. Okay, so authentication, authorization, isolation thanks to network policies out of the box. Now we start, wanting to isolate, what a potentially compromised function could do on the underlying system. And at the end of the day, it's a pod. So it's just pod security out of the box again. So, if you look at the pod that's running your function, there is a security context, okay? By default, we actually baked it into kubeless, and Andres did this. So we set, FS group run as user 1000, so that out of the box, without changing anything, it's going to run on OpenShift, because OpenShift has a little bit tighter security constraint out of the box. Okay, so by default, you get this. You get some security context. But then you also have the container that's the runtime, okay, the function runtime. So that function runtime has been built also, and that's just an example for from the Go runtime. We just announced Golang support. User 1000, so that's really the basis. So the server that's exposing your function doesn't run as root. That's really the minimum thing that you need to do, okay? I'm not saying that that's the best security, but at a minimum, you need to do this. So here you're now trying to limit what a potential compromised function could do. And then, of course, if somebody managed to get out of that container and reach your host, you would like to be able to limit the blast radius. So that's where things like kata containers come in, or I haven't had time to play with it, but the newly announced gvisor from Google. If you're running Kubernetes on hosts that have gvisors installed, then suddenly each of your pods are going to be really well isolated from each other. So it's just beautiful, okay? And I think it's a general tendency with well, it's not even a tendency. It's a general thing with technologies that we see convergence of things, okay? Everything I'm talking about here is just baked into Kubernetes, and then the availability of things like gvisor, okay? But it tells you why you end up with extremely secure functions. Now, by default, pods, when they start, they're going to have a default service account. And some of you may remember at the beginning in Kubernetes, there was no RBAC. So when you were running with a default service account, you were root on the Kubernetes API server. That was great. Okay. Now it's much more, restricted. So the default service account, cannot do much. And the other day, I was writing a function that was calling the API server to get secrets, and it was like, oh, cannot get secret. Ah, nice security feature out of the box. Okay, I was actually restricted to do things on the API server. So that means that what you would like to do is be able to run functions maybe with a specific service account. Typical thing in Kubernetes. So this week we did a demo with the folks at Sysdig, and we did a nice integration with their system Falco. Falco is an open source security, it's not a security scanning system, but basically you can define a set of security rules, and it's going to monitor all the system calls that are happening in your host, and if it detects an event that matches a specific rule, then it's going to trigger an action. So the integration that we did is that we are running Falco on a GKE cluster, and then we have some rules to detect Bitcoin miners. And when the Bitcoin miner is detected, it sends an image to NATS, and then the NATS event triggers the kubeless function that kills the pod. Okay, so we have an automated Bitcoin miner killer. But to be able to do this, we needed to be able to kill pods, and a default service account cannot kill pods, okay? So we ended up creating a service account and then using that service account for the underlying function. So how can you do this and kind of customize this? Kubeless has a config map that's it's cluster-wide right now. Ideally, we would try to build that as a multi-tenant kind of configuration so that every user may have a custom config for their underlying function. Right now, it's cluster-wide. So you edit that configuration, and then you can actually configure the deployment manifest that's going to be used for the functions. So if you want a function to use service account Falco, you just specify that in the config map, and every function that's going to start is now going to use that service account. So you've just locked it down even further. Does that make sense so far? Is it interesting or boring? No? Interesting? Okay. So that's internal security, and I think it's mostly out of the box Kubernetes stuff that you need to be aware of, and then turn on and understand how to configure. So now external security, that's it's a little bit more interesting from the actual FAS solution. That's not a Kubernetes feature per se, but you need to think about it from the kubeless, the FN, all those solutions. So mostly it's an authentication issue. Who can call your function endpoint? Okay, and then what can your function do? Okay. So in kubeless, you can do kubeless trigger HTTP create. Okay, so you can create HTTP triggers. How am I going to call my function? And that's really the basic. If it's exposed via HTTP, you want to call it over HTTP. You want to expose that function outside of your cluster. So with kubeless trigger create, kubeless generate an ingress object. Okay. So you have a set of options there to turn on TLS, to specify the secrets and so on. Okay. So more or less, in the kubeless CLI, you have a convenience wrapper to create an ingress object. And of course, that means that now if you're using an Nginx ingress controller, create a password, HTTP password, you create a secret to stick that HTTP password, and now when you define your trigger, kubeless trigger create, you specify -- basic auth secret, you make a reference to a Kubernetes secret. That's the beautiful thing about the system, okay? Everything falls in place. So you reference your Kubernetes secret, and now you actually have a basic auth endpoint to your function from outside your cluster, okay? This is just a property of the ingress controller, Nginx ingress. Yeah, and by the way, you see if you do a kubectl get CRD in a cluster where you have installed kubeless, you'll see that there is a CRD for HTTP triggers. So, all our triggers are defined as CRD objects. That's what I was mentioning. Of course, Nginx, it's one thing, and that just gives you basic auth. Maybe you want something a little bit more interesting than basic auth, and we just added, some support for Kong. So Kong is basically an API gateway, but you can program it very nicely, and you can get JWT token to access an HTTP endpoint. You can get API keys and so on. So if you use the newly announced Kong ingress controller, suddenly it opens the door to a lot of ways to access your function endpoints. Joe Bida the other day was asking on Twitter what to talk about at his Friday. Thank God it's Kubernetes, TGIK. And I suggested that he talks about security and security configuration and so on, because I want to authenticate to my Kubernetes cluster with my GitHub account. But anyway. And they have Gangway. I haven't had time to play with it, but it's a utility to be able to authenticate to Kubernetes with different systems, and I think they have a plugin with auth0. That's very interesting because I think if they were to put Gangway in their ingress, we could secure an HTTP endpoint, kubeless, using auth0. And the serverless community, the users of serverless, they are very, very keen on auth0 as a way to manage security to their APIs. So it would be a perfect combination to get an auth0 authentication set up there. Yeah, and yesterday I was finishing the slides and I realized that in the abstract I said I was going to use EKS, but I didn't get access to EKS. So yeah, there is no EKS content in there. I apologize. So now let's move on to external service authentication. That's where it gets interesting, because those functions that are glue between cloud services, those functions, they need to be able to do things with the cloud. So typically that means that they need to have access to some type of service account to talk to cloud storage or talk to Kinesis, Cloud ML, you name it. So how do you give a pod function an identity so that it can do things? If you are on AWS, you can use a system called kube2IAM. Kube2IAM. Okay, and with this, you can annotate a pod, and that pod will get access to the role specified in the annotation. Okay, so that's great. That's very helpful. In kubeless, it gives us a little bit of a problem because now we need to add some convenience in the CLI to be able to provide an annotation, and then different functions may have different annotation. So we need to think about how to enable that, nicely, but it's totally doable. And on GCP, it's a little bit easier because you can just reference a service account with an environmental variable. So create a service account in your Google Cloud Console. download that service account in JSON file, and then you need to just make it available as Google application credential, okay? And then you get it. And in the kubeless CLI, you see that you can specify an environmental variable, and you can also specify a secret, and then we'll automatically mount everything so that the function has access to that secret, and it's defined as an environmental variable. So you do this, and now you can talk to things. I'm going to did your container download? Yeah? Okay, cool. So I don't need to keep talking? Okay. So I'm not going to do this demo, but that's just to give you an idea where we're going with kubeless, specifically to talk to cloud services. There's just a prototype there of a mini Python controller that monitors ingress objects, and when it sees an ingress object, it makes a call to the AWS API gateway and registers the route in API gateway. Okay. Why did I do this? Is because we package this as a little pod running in the cluster, and it monitors what you're doing with your kubeless system, and then suddenly you get the API gateway that, programmed automatically. And if you look at the call I'm making to the API gateway, it says authorization type none. If I want, I can just say authorization type AWS IAM or Cognito. And that now I fall back in the AWS land, and I can actually give an identity to or secure that function endpoint. So we have lots and lots of potential here. So with that, I'd like to let Johannes show us how he's actually leveraging another system that converges with Kubernetes, which is of course Istio, that helps us secure even more function environments.
Can you hear me? No. Awesome. That's the wrong screen. So let's try to move all the stuff over. Here we go. The first one. Oops, sorry. There's something you should not. Oh, wait a second.
Istio is an open platform to connect, manage, and secure microservices. As kubeless is based on Kubernetes deployments, Istio can be applied easily to kubeless. During this demo, I would like to show you how you can easily expose and secure kubeless functions using JWT token as well as RBAC rules to secure the communication between services deployed to the Istio service mesh. First of all, the demo architecture, it's based on etcd. We have a product service and a commons function, so a product function and a commons function. And all this is displayed via a web UI. To make it a bit more interesting, I built a small beer shop. All this is exposed via an Istio ingress controller, via the Istio ingress controller. It is working like every normal ingress you know about, with the addition that we have to have an annotation to use the Istio ingress class. The functions are both pretty easy, so we have a product service, or the product service is able to get all the products out of the etcd as well, or if we provide a path, it's able to get one. The comments function is looking similar, so I won't show it again. In Istio, I enabled mutual TLS. By enabling mutual TLS, you make sure the connection between the envoys inside the service mesh, so between the sidecars, is encrypted, as well as server and client are authenticated using the SPIFFE protocol. I won't go into any details here, as it is not an Istio talk, but with this system, you can make sure there is no man in the middle between services talking to each other. First thing I like to do is, as the beer shop is already exposed, I like to disable the comments functions from people who are not authenticated. So if you have a look onto the details page, you see comments to the selected beer, and to apply an add JWT authentication to a service, you simply have to write an authentication policy. In this case, we're restricting the common service and allowing only connections from people authenticated by this Google service account. So let's apply this. And I will already get an JWT token. So if we refresh the page, there are no comments shown. So let's quickly log in with our JWT token, and now the comments are shown again because the authentication was successful. In the next step, I would like to restrict the access to particular services using RBAC rules. So the RBAC rules are done in the Istio mixer. So we are sending the request context of each incoming request to the service to mixer, where the Istio RBAC engine is evaluating the RBAC policy and then allows or denies the access. That said, to enable RBAC, we have to first define the request context. This is pretty much the configuration from the Istio documentation, so I won't go into any detail. In the second step, we have to define an RBAC handler or configure the RBAC handler, and finally we have to map that every request inside the default namespace will be redirected to the RBAC handler using the request context we defined earlier. So, and if we applied this, the entire all the connections are denied because we have not defined any rule to allow access to the web UI and the product service. To do so, we have to add a service role, which is allowing all methods, so get, post, update, delete, and so on the product, beer shop, and comments service. For demo purpose, I have excluded the etcd cluster. We will enable it later. And what we have to do, we have to map the service role binding to the Istio system namespace. This is the place where the Istio ingress is located, and for internal connections onto the default namespace. So quickly apply this. If we refresh the page, now you can see the page is loaded fine. The only thing which is not loaded is are the products, and the reason is the server got a 500 error because he is not allowed to connect to the etcd database. So what we have to do now, we have to enable connections to the etcd database, and after a few seconds it should work. Here we go. Last but not least, the comments are still not shown because we still have to add the JWT token. The RBAC rule is just validating that that the connections are from the Istio ingress and not from somewhere else. that said, we're at the end of the short demo. I think Istio is a super good fit to kubeless, as it is enabling a lot of security options which are not there by default. There are still some limitations. So to enable mutual TLS, we have to apply you have to implement a short workaround to disable the liveness probe. The reason is Istio is not allowing any liveness probes from Kubernetes. This will be fixed soon, either on kubeless side as well as on Istio side. And the kubeless CLI is not fully functional with mutual TLS, as the kubeless CLI is using the Kubernetes proxy to connect to the function, which is not part of the Istio mesh. But I guess we will have a solution there soon too.
That's it.
Thank you. Thanks, Johannes. That's great. He had to stream down a little bit the demo, and then the mutual TLS was a little bit complicated. That's because we need to exclude the else check ports and the metrics /matrix route from the Istio setup. Is that it?
This is the solution to the problem. The problem is if the mutual TLS is enabled, Kubernetes itself cannot access any ports, and as well as you cannot get through the proxy endpoint the API server is providing to you to the services. So, cool. And the solution will be to have 2 ports at the end.
Great. Thanks. So that's coming in kubeless, and that will give us mutual TLS via Istio, which means that now we have the full power of service mesh, and we can deploy functions within a service mesh. Those functions will be triggered on events, and we'll be able to call other cloud services. So the conclusion, Kubernetes provides you with all the API objects to secure functions. A lot of this is out of the box. You just need to know it's there and then configure it properly. Keep an eye on kubeless. Look at the way that we're handling events with new triggers. We announced NAT support, which is really exciting. So you're going to see Kinesis support soon, and that's even more exciting. And then follow us on Twitter, and thank you very much.